Oh, this is for section 9.1 sequences. So what is a sequence? A sequence is a function a of n where the domain is the integers or natural numbers. Because sequences are used so often, we usually abbreviate the notation a of n to be a sub n. Example 1, write out the first 5 terms in the following sequences. So a1 would be 5 to the 1 minus 1 over 3 to the 1. 5 to the 0 over 3, which is 1/3. A2 would equal 5 to the 2 minus 1 over 3 squared, which is 5/9. A3 was 5 to the 3 minus 1 over 3 cubed, which would be 25/27. A4 would equal 5 to the 4 minus 1 over 3 to the 4th, which is 125/81. And then A5 would be 5 to the 5 minus 1 all over 3 to the 5th, which is 625/243. B is very similar. So B to the, but notice that K is greater than or equal to 0, so we actually start out at 0. So B to the 0 is negative 1 to the 0 over 2 times 0 plus 1, which is 1. B1, negative 1 to the 1 over 2 times 1 plus 1, which is negative 1/3. B2, which is negative 1 squared over 2 times 2 plus 1, which is 1/5. B3, which is negative 1 cubed over 2 times 3 plus 1, negative 1/7. And then the fifth term here will be B4, which I'm running out of room, so it will be 1/9. Now C is called set notation, and notice how n starts at 1, goes to infinity, and we have 2n minus 1. So the first term would be 2 times 1 minus 1, which is 1. The second term would be 2 times 2 minus 1, which is 3. 2 times 3 minus 1, which is 5. 2 times 4 minus 1, which is 7. And then 2 times 5 minus 1, which is 9. So those are the first 5 terms of this sequence. Now D is defined in a recursive relation where F0 is 0, F1 is 1, but then F2 is F to the 2 minus 1 plus F to the 2 minus 2, which that is F1 plus F0. And we already know F0 is 0, F1 is 1, so that's 1 plus 0, or 1. So in other terms, this is the Fibonacci sequence we talked about in class, and you just add the previous 2 terms together. So the previous 2 terms here would be 1 and 1, so F3 is 2. F4, the previous 2 terms would be 2 and 1, so F4 is 3. I know that's the 5th term, but let's just do one more for good measure. F5 would be 3 plus 2, so 5. So those are different ways you can find the terms of a sequence. Now, what is an arithmetic sequence? An arithmetic sequence is a sequence where you are adding some constant value, which we'll call D, to a term to get the next term. For example, if we have 4, 8, 12, 16, 20, so on and so forth, we're adding 4 to each term to get the next term. D is called the common difference. A geometric sequence is a sequence where you are multiplying some constant value, which we'll call R, to a term to get the next term. For example, a very common geometric sequence is 1, 1/2, 1/4, 1/8, 1/16, and so on and so forth. So you're multiplying by 1/2 each time to get the next term. And R is called the common ratio. Example 2. Determine if the following sequences are arithmetic, geometric, or neither. If arithmetic, find the common difference. If geometric, find the common ratio. So A, B, and C are the terms we have already came up with. So we get 1/3, what was it? 5/9, 25 over 27, 125 over 81, and 625 over 243. This is what we came up with in example 1. So I'm hoping you can notice that if I take 1/3 times 5/3, we get 5/9. And if we take 5/9 times 5/3, we get 25/7. And if we do this to each of the terms, we get the next term in the sequence. So this is geometric with D equal to 5/3. B, we had 1, 3, 5, 7, 9 from example 1. I'm hoping here you notice that we're adding 2 between each term. So this is arithmetic. And our common difference is 2. I have to go back to part A. It's the common ratio for geometric, not difference. So R equals 5/3. Now C, this is our Fibonacci. So 0, 1, 1, 2, 3, 5, and so on. Well, it's definitely not arithmetic because you see we add 1, add 1, add 1, looking good, add 1, looking good, add 2. It breaks it there. It's not geometric. We're going to ignore the 0 because that poses some other properties, but it's multiply by 1, multiply by 2. So this is neither arithmetic or geometric. Now D, if you stare at this long enough, hopefully you can see if you multiply by -3/2 to each term, you get the next term and multiplied. So that means this is geometric with r equal to -3/2. I'm at a little over 10 minutes, so I'm going to stop this video here and continue notes in the next video.